Hi everyone, thanks for joining us today.
It does sound sophisticated.
Sophisticated, yeah.
With the ACE community for 3 years now.
Actually outlined everything.
Something that we find in the society.
First, talk about the problems that you're trying to solve.
Hi everyone, thanks for joining us today. We are here with another episode of Deep Random Talks. Today we have with us Dr. Joel Chan as well as Amar, my co-host. We are going to talk about tools for thinking, knowledge sharing, expertise sharing, and data structures, and a lot of other topics related to that. Those of us who do thinking for a living probably have noticed that that process is becoming increasingly a multiplayer human-machine interface. And today we are going to go into many different aspects of that. So before we get started, Amar, what's new with you?
Oh, well, I guess like most folks here, I'm just coming back from a relaxing December break. This time around, I had a nice chance to visit family, so unusually refreshing. Yes. How have things been on your end, Amir?
Yeah, very good. Also, spent some time with family and back to reality now. So let's get to know Joel a little better. So Amar, you had some questions you wanted to ask.
Yes. Before questions, I'm just going to give our audience a 30-second quick intro on Joel. So Joel is a cognitive scientist by training. He's currently working as an assistant professor at the University of Maryland, focused on information studies. And he spent a fair bit of time studying how engineers and scientists do creative problem solving. And more relevant to our audience, the underlying data structures that enable and accelerate that creativity at the team level, if I can say that, Joel. And it's just so nice to have you here today.
I'm glad to be here. Thanks for having me.
Sweet. So I'm going to start off with a little bit of a rapid fire.
Okay.
Do you want to give folks a sense of where you're located right now and what place you call home?
Sure. So I live in a small city called Hyattsville, Maryland. I'm about 15 minutes away from the campus of the University of Maryland College Park by bike. So I could commute in to and from door to door in 17 minutes. Pretty close to Washington, D.C. That's where I call home.
Sweet. And are you working on any interesting side projects?
Yes. So at the end of last year, I finally bought an electronic drum set, which is behind me, if you can see it. I've been a drummer for quite a while, but once I had kids, it became hard to find time to play the loud acoustic drums in a house. There's really no place for it. But it brought me a lot of joy. And so now I have this, and now I'm starting to learn recording. I'm getting practice rudiments. I'm jamming to different genres of music. It's just wonderful.
Glad to hear that. And before jumping into the meat of things, Joel, I'm looking for the dinner party version of how you describe what you do.
So I'll give you two versions. So the most recent thing I said was I'm confused because I told people, in the last week, I messed around with some large language models and problem engineering. I thought about Foucault and Latour and science and technology studies. And I did some qualitative analysis and I ran some statistics. So I'm all over the place, but there's a unifying thread. I tell people now that I'm a person who studies what I call creativity support systems. So I think about how we can build systems broadly construed, ranging from search engines to organizations to interfaces that help people do creative work in domains such as science and engineering. And I come at it from all angles. Applied machine learning, HCI, cognitive science, information science, social studies, just to get all angles on this kind of really fun, meaty problem.
So, Joel, you started as your PhD studies were in cognitive psychology. And then in your postdoc, you moved in more into the area of human-machine interface. So take us back there. What was going on? What was your PhD about? What was your postdoc research about? And probably early academic career. Take us back there.
So I actually went to grad school to study how people learn. I was interested in that, and that's always stuck with me till today. But I was interested in peer learning, peer review, which in retrospect is really about sharing knowledge with each other. You can see the connections to crowdsourcing. Turns out my advisor, Chris Shun, at the University of Pittsburgh, he didn't have money to work on that project. So he was like, hey, I have this grant for 3 years to study engineers and creativity. Try it out. If you like it, great. If you hate it, we'll find something else. And I tried it out, and the rest is history. What's interesting is I was actually doing human-computer interaction research from the very beginning. I just didn't know it. The project was in collaboration with some mechanical engineers at Carnegie Mellon, which was just down the street. On the team was Jonathan Kagan, Kevin Kotowski, Kate Fu, and Chris Wood from UT Austin at the time. And we had this ambitious idea for what we called the Verrocchio project, which was basically a search engine for designers to input their problems, whatever kind of interesting design problems they're working on, and we'll search patent databases and return inspirations not based on what's relevant or similar to the problem you're working on, but to give you interesting analogies, right? So one example problem that we worked on a lot was, imagine you're an engineer and you're trying to design a device to generate electricity from human motion in rural places when you don't have access to the grid. You can imagine analogies to all kinds of interesting things like that generate electricity from human motion or transfer, motion from one to another. You've got dynamos, you've got piezoelectric systems, you've got kind of earthquake systems. So that was the idea, and there was a lot of interface work and retrieval work that I still do today. So that's where I started, and I'll tell one story. Technically, I was in cognitive psychology, but I felt very out of place actually in the core of the field. Went to the main conference in my field, psychonomics. I think of my first semester, and I remember being so bored I couldn't bring myself to come out of the room. No knock on that research, right? So very kind of reaction time research on how fast people read and so on. Cool stuff. I just didn't care for it. What I found myself excited most by was cognitive science studies, where actually we will call in vivo studies, where we'll go and look at people actually doing stuff, like scientists working or designers working. That was what excited me.
So for a while you were looking at engineering processes and design processes, but at some point you focused specifically on a patent search engine, and you explored a lot of things around patents or written documents, and analyzing written documents like those.
We ended up working a lot with text analysis and text mining systems to try to explore how do we structure these patent databases. They're organized by sort of like technological area, so almost like categorically and hierarchical, which isn't necessarily what you want when you're trying to search for interesting inspirations. So we're trying to look for things based on analogical similarity, like analogy relations. So like you think about the solar system and the atom, they're not necessarily in the same category of things, but they have a shared structure of like there's a core body that's orbited around by smaller bodies based on gravitational pull. So we had thought a lot about how do we add structure to these. Essentially, if we threw out the categories, then it's essentially unstructured full text, right? How do we actually search over that to help you find things that are analogically related to your design problem? The things we tried back in the day were what we call generative models, Bayesian models of Bayesian structure modeling, and we would sort of feed this text input into these models, and they will create these like sort of graph-based structures to kind of see how things relate. And we would sort of play with throwing out parts of speech like nouns and care about like verbs or functions, and then structure it based on that. And you get some interesting ways to explore things that are related that are not, you wouldn't think are related based on the category.
The main problem that you eventually ended up focusing on was how do you structure stuff in a way that it induces or accelerates creativity. And your first kind of jump into that was rethinking how to organize these patterns in a way that you'd find interesting analogies. How did you go from that specific example to more broadly thinking about data structures, though?
One of the seeds was, I was really interested in sort of in vivo studies, and my advisor actually studied a lot of scientific thinking back in the day, and still continued to think about it. And we actually had access to this really interesting data set of recordings of the Mars Exploration Rover project. So the Spirit and Opportunity rovers in roughly 2004 that found evidence of water on Mars, and we got to watch all these videos of the scientists like hanging out and talking through problem solving and using analogies, and we just got really interested in like the kind of the twin domains of design and science. So that seed was planted, and then during my postdoc, I think because I started getting into human-computer interaction research, the line between design and science starts to blur a little bit. So I got very curious about if I'm a design researcher, I don't just care about how people do things. I also need to know about what do we know about what users need, what their constraints are, what the problems are, and there you start to dip into science. So if you're thinking about like I want to solve this like policy problem, there's like ways that people have solved it, but also what are people responsive to? What are the actual core underlying problems, the constraints? And so you almost need to pull all these things together much more than just like this is a patent solution for this problem, but you need to sort of like understand what are the situations that have similar constraints or situations that have similar problems or phenomena, as opposed to just like similar problems and solutions, which would be sort of a nice organizing structure for patterns, right? You've got these functions, you've got behaviors, you've got structures, but you need to dip into science. You need to have theories, you need to have empirical findings, you need to have these models.
That's very interesting. So for a lot of practitioners, the kinds of examples that come to mind are similar use cases or similar implementation.
When you think about that way, if you reflect carefully on how you think about what is relevant or not, you need more than just, they were working on a similar use case, right? For example, if you find out, like, say, I find out Amar tried this 3 years ago and it didn't work. Does that mean I just throw out that algorithm? Probably not. I need to understand the particulars of Amar's situation and how it maps to my own, right? What are the constraints? Who are the people, right? What are the phenomena that's going on? Is the same thing that sunk the project then? Is that going to sink me now?
A lot of your early career was coincident with what people talk about in the context of knowledge sharing and knowledge management as repository models. Like essentially when we thought that it's a good idea to externalize as much as possible and make it as objective as possible and try to collaborate on it. But at some point and I think after the patent search engine that you were working on, you moved on to working on scientific literature more specifically. But around the same time, there was also sort of a movement in the field as a whole after the realization that complete externalization of knowledge is just not going to work. Like there's a lot of tacit knowledge, there's a lot of interactions and expertise sharing that is required to do effective collaboration, and sort of like you moved on to studying how people worked in general when it comes to knowledge artifacts.
I'm going to say this a lot, right? Because the area that I'm in is so interdisciplinary. There's so many situations where I found myself rediscovering like a whole field that has been thinking about this for a long time. So in this case, this was the field of computer-supported cooperative work that's been thinking about knowledge sharing and expertise sharing since the 80s. And I didn't know about it because I came from cognitive science and I was new to HCI. And I was like working on this problem of like, if Amar has a cool idea, I would like to have access to it and be able to use it, right? That's essentially knowledge sharing. I was thinking about it in terms of like externalized databases. But it turns out like when you think about the actual mechanics of building these like knowledge sharing systems, the field of CSCW, their strength was actually going to study these systems in actual deployment and understanding when and why they work or don't work. More often than not, they don't work. for lots of different reasons. But one of the interesting things that stuck with me is think about how much information you need in a record, right, of or a document in order to actually use it, right? So if you say like, Amar has this cool idea, and I give you the name of the algorithm, right? If you know how it works, then you can maybe run with it. But if you don't, then you need more information, right? Like, how do I actually run it? Like, what are the edge cases, right? All of this is like contextual knowledge, and a lot of it's not written down. Some of it's tacit. And what we find is that in these kind of knowledge sharing communities, this contextual information that's needed is often either impossible or just really annoying to put into a database. Like, you just can't like anticipate all the things that people might need to kind of bring in as context to actually make use of the thing that they given to you, right? So it doesn't matter if I make the connection and say, hey, Amar did the thing, you might find it useful. And if I don't have access to Amar, I'm host, right? Like, I've got this like inert thing, this name of a thing that could be useful, but it's not useful. Like, I need all this contextual information to actually make use of it. That's one of the big reasons, big failure modes of thinking from a repository model, where you only think about what's in the database and say, we're gonna connect people to this bit of information and we're done, right? And so the reaction to that in CCW was, you need to connect people to other people. As one of the main ways that you get contextual information. You can try to put a lot more stuff into contextual information into the record, and under some circumstances, if you have a good idea of like the potential use cases of the information, then you can anticipate all the different things that you might need to know. But in the case of like frontier pushing creative work, you can't really anticipate where Amar's cool idea is going to be used and what they may or may not know. And so that's why this sort of like movement moved away from thinking about only what's going into the database to thinking about how do we support connection between the people who need the knowledge and the people who have the knowledge, and how do they work together. If I give you access to a thing that might be relevant, but you lack the contextual tacit information and knowledge, then I've actually not helped you at all. I've just given you more homework to do, and there's nothing that you can use from that like little record that I sent to you. And so one of the best ways that we know to access this tacit knowledge is in people, right? You go talk to Amar, and actually he'll show me like the code on your machine, and like you'll show me like all different examples. So that was the sort of like kind of big move. And it's related in my head to like, there was a lot of excitement around like in my field, expert systems, trying to sort of externalize all this information into a database that's essentially self-contained, such that you can essentially run reasoners over the knowledge and generate inferences and ideas and so on.
So there were all these cool ideas that you were kind of jumping into. But what I want to really ask is, what niche did you decide to pick for yourself? What did you decide that, yes, this is the part I want to focus on, this is what I want to achieve?
Right? It's not that we don't need databases. And in fact, one of the failure modes is to say only people matter, stuff doesn't matter, artifacts don't matter, databases don't matter. I think that's a mistake, because you still need to have like something to look at, and some to talk over with, and something to use to connect people to figure out like, okay, maybe I should talk to Amar. And the problem that really captures my attention is, how do we, again, going back to the idea of organization and structure, how do we add these like structures on top of these collections of people and artifacts and resources, patents, papers, and so on, to enable people to make these like connections in useful ways. There was a lot of excitement, I think, around the time I was working on using completely automated text mining approaches. And I think you can get some of the way to sort of like, do text classification and try to, pull out structure and name entity recognition and relation extraction. Those kinds of things can get you some of the way. But when you think about like, for example, modeling what is in a research paper, right? What are the entities in there? What are the relationships? What are the key findings and implications, people are way better at pulling those out than machines are right now. Who knows what's going to happen in the next few years? But there's this question of how do we get that structure, right? So one way is to sort of like use machine learning completely to end, add that structure either on the fly or autonomously or separate from humans. Another pattern that was very popular around the time I was working was human computation, crowdsourcing. We'll sort of like go to these like labor markets, online like crowdsourcing markets. We'll break down these tasks into micro tasks of like, hey, look at this paper, and here are 5 potential concepts. Which ones are actually in here? Or like, here's 3 things. Which one is most similar to each other? You collect all these judgments and you build a structure. I was very dissatisfied with these solutions because the machine learning approaches are, they're sort of cheap, right? Like they don't cost a lot of money, but they didn't get the right kinds of structures. The crowdsourcing approaches were okay, but they were really laborious. You have all this training you have to do. It just didn't feel right. And it was like sort of like separate from the thing that caught my attention so much was like, you and I are adding structure all the time. When we think about these, when we read the paper, we take notes, we highlight, we talk about all these structures that are needed in order to connect people to each other, right? When you talk about an essay, a paper, like, hey, what was the key interesting finding? Or what's the key trick that was in this technique? What was the algorithm, right? We talk about these things, we write down these notes, and then we throw them away, right? Like we don't use them at all. That's actually the thing that we want, the structures, that metadata that we want in order to. And so right? I was like, I just got really like frustrated. Like, how do we harness this work that we're already doing? I experimented with this with collaborators, my postdoc advisor, Stephen Dow, and we worked with Christoph Gahos, who was at Harvard, and Pao Sangnelu at the time. And we played with this idea of like shared whiteboards in the innovation community where with a similar idea, when you put people in front of a whiteboard and you have them brainstorm, you naturally start to cluster things. I don't have to tell you to do it. You just want to do it anyway. It turns out there's so much information in there, right? There's like these co-occurrence patterns, this data. And all we did was we noticed that there was this thing that people were doing that had information. And then we built a machine learning system on top of that to recognize the clustering and then build an idea space using the pairwise semantic judgments from the thing that people were just naturally doing. They were just putting stuff together in clusters on the whiteboard. And then we were able to compute pairwise similarity matrix on top of that and then build an idea space. That design pattern we call integrated crowdsourcing, and that's really stuck with me as distinct from like a sort of paid microtask crowdsourcing model. The key difference is, in this case, the people who are doing the work are not being forced or paid to do stuff. It's integrated into the work that they're already intrinsically motivated to do. And I like that pattern so much because it feels a lot more sustainable, right? We don't have to like constantly raise money to run these like crowdsourcing tasks. We don't have to like build these giant training data sets for the machine learning models. We just have this self-sustaining system where the people who need the structures are the ones also generating it because they just want to. When you're reading papers, you want to think about it that way. And how do we then contribute that to the community, contribute those structures? That is the idea that has stuck with me until now, that kind of start in the postdoc. That's what I want to work on. It's like, how does it show up in different situations, from the simple situation of like whiteboards to more complicated settings like a machine learning organization or like research literature, right? What are these like structures that people are already doing? How do we sort of harness that and contribute that to the community?
You're saying that folks are just creating these structures as a byproduct of what they're doing, just scratch notes, creating stuff or putting stuff up on Miro, and you're thinking about using that essentially as training data.
That's one way you could do it. Yeah. So that's what we did. If you wanted to feed that into sort of a information retrieval model, like build some machine learning model on top of that, in some cases, you can just use it directly as like metadata for the documents. you think of those like annotations, right? So you can imagine those as tags, for example. That's more and more descriptive. So you could do that.
So Slack is a tool that all of us use every day significantly. Nobody forces us to answer each other's questions, but we always go there and answer each other's questions. We always integrate artifacts into the conversation because as I'm typing an answer, I might link quickly to this article that I recently saw that answers a Mars question, or I might paste a picture about an idea that I literally drew on, a piece of paper. Like this is a very manual process, obviously, right? Like because we are curating the knowledge, we are immediately recontextualizing available knowledge. Because if I say something and Amar says, "Well, actually, my context is slightly different than what you said," I can immediately correct what I said, or he can ask follow up questions and say, "Are you making this assumption?" So there is sort of like a negotiation happening over existing knowledge, enriched with a lot of externalized artifacts. Is that the holy grail we should be moving towards in terms of knowledge work, or is that even the right way to think about it?
I am very excited about that kind of thing, right? And I think the way you're thinking about it is exactly how I would approach this particular setting, right? Like you get excited, like, wow, we're using these chat systems where the conversations has all this like latent structure in it, right? That's in our conventions, right? Um, what are the hidden conventions that people are using already that are super useful to them, right? Maybe there's a norm in that chat of like every time I post something, I can expect somebody to try to dispute it, and they'll put in like a source, right? There's a structure right there, right? There's a dispute relationship between something I'm putting in and someone else is putting something in, and there's a source, right? There's a latent structure there, right? How do we return to that if I'm coming up with a similar idea like 5 months down the line? How do I find all the things that dispute that idea so I don't rehash it, right? That's a structured query, right? That if you had the actual structure of like, this is a thing, it's disputed by this other thing, right? Maybe it's like a claim and a source, disputed by source, right? 5 months down the line, if the system recognizes them, I'm going down this path again, I'm going down to this claim, right? We don't have to rehash everything. We can sort of retrieve, oh yeah, we talked about this 7 times over the last like year. Here are all the sources. Let's start from there instead of starting from scratch again, right? Like that, I think it's so exciting because you get so much more like this idea of like standing on the shoulders of giants, not starting from scratch, right? Being able to sort of see further, see faster, stand higher, because you're not always like going from zero again. There are lots of design questions around how do you get that structure, right? People express these structures often very fluidly. They're not necessarily machine readable, right? So there's a lot of questions about how do we translate these like latent structures into more what I call like machine usable structures that we can then feed into information retrieval algorithms and so on. Those are open questions that I think are very exciting and connect a little bit to kind of recent developments in language models that seem to excel at translating from one kind of structure to another kind of structure. So I'm really excited about, like if there was an agent that was like listening on your chat and you sort of like define the convention and learn the convention. Every time Amar is about to dispute me, it's going to look like this. And so you can recognize, aha, a dispute is happening here. And you can sort of like turn that into an explicit structure that we can refine or, do, as opposed to like requiring Amar to use exactly the same words every single time or to like fill out a form. That's never going to work because like it's going to break the flow of conversation. So how do we like not minimally change the way that you're doing your work or talking to people, but still be able to capture that interesting structure? Those are like really questions that excite me a lot. I would call that a holy grail because how do you sort of not interfere with the work, but you still capture that byproduct, that wonderful creative exhaust?
It's a very exciting kind of standing on the shoulders of giant kind of experience. That's really what you were trying to, and I can say you are trying to achieve. We got the initial inspirations kind of combining whatever structure is natural maybe with a layer of machine supported organization. But when rubber hit the road, when you actually tried kind of applying this, what were some major pivots that you had to?
This is now, let me go back to my postdoc where the naive way I went about it was something like what I said before, which was let's get people to write these explicit structures, right? So we'll enforce formalisms and conventions, right? So Amar, you can no longer be informal about your disputes. Every time you dispute something, you have to use exactly this template, right? And we can predefine all the templates that we can imagine wanting to use, and everybody's going to agree on it. And it's going to be great. That is a horrible thing that I thought would work, and I spent some time on it. And then again, like as I said, I'm going to say this a lot. I came across this paper from 1999 called "Formality Considered Harmful," right? Why interactive systems designers often try to impose formality and structure on users, and why it almost always fails, right? What are pitfalls? So that was like kind of a major pivot of like trying to think about what are other design patterns for capturing structure than forcing people to change the way they work to fit a specific convention only, which can be very powerful if the task domain is very stable and everybody agrees on what the conventions are. That's not the domains that I'm interested in working in, right? If we can just predefine, there's only 5 kinds of things that we care about and only 7 kinds of things that we can do, and only those. In those situations, we can potentially force people to only use predefined moves, right? If you imagine like a simple game like Tetris, right? There's a simple set of like possible moves. It's a closed world. But in conversations, it's fluid. The problem domains, they shift. People might be interested in ideas. They might want to make distinctions between. I don't quite claim that. I hypothesize that that's the case. I'm not actually disputing you. I'm like questioning, right? There's all these nuances in conversation that if we force the people to fit into, no, it's all a dispute, it sort of like, breaks the flow of conversation and like forces you to not be able to. Instead, what we do is we go to communities and we observe what are some emergent structures that people use, what are the most interesting ones that they use, give them the tools to explore and define structures that are useful to them, right? So if they keep repeating themselves, that's a signal that there might be a structure that we can ask people to try to use. But we never restrict people to only be able to say things in that predefined structure. We try to integrate that structure into the streams of work that they're doing.
That must have a lot of edge cases, though.
It makes you feel bad, doesn't it? Right? To think about like there's all these things that are not being captured. There's this wonderful paper describing the history of the semantic web. It's called Neat versus Scruffy. The kind of tensions between there's a neat style where you want to have a clear ontology where you cover all the edge cases and you completely describe a domain, and then you can have nice properties of semantics for inference and so on. And then there's a scruffy style where you recognize that there's lots of edge cases that you're not going to catch, but what matters is whether people are able to get value out of the structures that you've created. So if there's like inconsistencies, but people are still somehow able to, use the system to retrieve things more often than they would have otherwise, that's a win. It's scruffy, it's messy, right? But it's probably a better fit for the mess of kind of real work. So it's an interesting tension as a system designer, right? And often, like one of the things that's good is to try to think of all these edge cases and try to cover them. But I think for me, like as a mental shift of like focusing on usefulness in practice as the key metric for how good is the structures that we have, as opposed to trying to cover as much of the domain as possible.
So I'm a product person and I like writing requirements for a system I'm creating. So if I were to create a system that has the properties that we've been talking about, I probably want to have a system that recontextualization in it is easy. aka if there is a piece of information, I can, pick it up and reuse it because I can, it was decontextualized when it was externalized, when it was documented. So I can pick it up and adapt it to my new use case, right? So recontextual, and people are probably the best sources for recontextualization, right? Because if I know Amar has written some, sorry, Amar, we're just using you as an example here, but let's say Amar has written down something and I want to reuse it. So, it's probably my best bet to just go to him and say, what was the context of this? How does this adapt to my context, right? So that's one factor that I want to make sure I get. The other factor is maintenance and availability. Like how much ongoing work do I have to do for this system to sustain itself? Because if Amar is on vacation and I'm trying to repeat something that he's done, and he's the only one who knows that little knob that you had to turn, then the whole system falls apart. So, the ability to maintain the system in a way that on an ongoing basis it works and it is available just in time is very important. At the same time, we talked about UX, like, how are you combining all of these factors in a way that I get the information when I need it in the context that I need it, et cetera, et cetera. But I think one thing that we didn't touch on a lot is factuality as well. Like, because, Amar might ask me a question and I might provide an answer that is a poor recall of what it was. Or, I'm just not in the right state of mind, so I say something that is not correct.
In terms of factuality, it's interesting because I actually don't really think about that a lot because I'm often thinking about creative inspiration. So if someone makes a claim, for example, that social media increases polarization, right? Is that factual? Is it going to lead me astray if I'm designing a system, if I assume that's true? In those cases, the way I think about it comes back to context also, right? How do I reconstruct the provenance behind who asserted that social media increases dysfunction? What is the evidence that they have that they're looking at that persuades them that this is true? How is it similar or different to the evidence that I have in front of me? And on that basis, then I can then, with that contextual information, I can reuse because I can judge to what extent I'm willing to accept that claim. That's how I think about it, right? But the specific example that you gave, maybe some examples are closer to like, if someone says like, how do I spin up a container instance for a Jupyter Hub thing if I want to deploy, right? And then Mars tells me okay, I'm gonna say like, if I say you can't do that, instead you only are able to use Windows machines, and it turns out that's false. What do we do with that? That's not something I think about a lot, but that is something I would think about as connecting to systems for reputation, for fact checking.
Okay, yes. So the question of factuality is becoming even, bigger because now we have a new toy in the toy box, right? Like the large language models. And, so far, all the things that we touched on where, there is a lot of documentation, like just free format documentation that people have done. There are a lot of structured documentation, like the data sets, like ontologies and taxonomies and like literal data, etc., that we had, and a lot of human interactions that we had available to us. So far, all of the systems we've been designing, had some combination of all of these components. But now we also have, large language models, which is a very interesting addition to the combination because to some extent they address the problem of accessibility and maintenance, right? Because I can train this once, if done properly, it can answer a lot of my questions, but then it comes at the cost of, hallucination and, not necessarily being factually grounded, but also not completely trivial in terms of how it interacts with other components that we've been talking about. So what are some of the things that you've been excited about and some of the things that are, big questions on your mind on that front when it comes to knowledge work and how we like knowledge work, not in the sense of creative, like I want to write a story in this style or I want to write a copy for my website, but in cases where the factuality of the knowledge matters, like when you're, for example, doing technical work using the knowledge that you're getting from these systems.
Yeah. I'll start with what I think is not the way to go, which is to, I think maybe it's a straw man, but I actually do see people get excited about the possibility of we'll never have to structure anything anymore. We'll just write and dump things into a database and we'll feed it into the large language model, and then it will structure it for us. And we can just ask it questions and retrieve things. I am worried about that approach for hallucination reasons, but also it's unclear what kinds of structures these large language models actually encode, having been trained on all this, huge data sets. We're still trying to understand what structures they actually encode. So I think it's a little bit risky for the kinds of things I'm interested in, right? Like it's not clear to me that structures like theories and findings and lines of evidence are encoded in the language model. So then you think about what do we do? What's useful with the large language model? So you can think about things like fine tuning for a particular domain. That I think gets a little bit more towards what I think is useful. Some patterns, though, that I think are really interesting are using a language model as a more useful natural language interface on top of a knowledge base, translating between natural language intentions and structured queries over a database, for example. I think that has some promise as a way to also deal with the hallucination problem, because you're not using the language model to tell you what the answer is, but to translate that into a query over a database that is then what you use. So there's some recent demos of hooking ChatGPT up to Wolfram Alpha. There's the GPT index project that people can use to sort of index their databases. There's like kind of design patterns around, I'm not going to take the answer from the language model, but I'm only going to care about the ones that can be grounded in a thing that you retrieve. So again, it goes back to context and provenance, right? If the language model asserts that X is true, if I can't see the things that it's using to construct that assertion, then I can't really assess whether it's factual or not. So that's an exciting pattern. Another exciting pattern is related to the idea of translating to a query. Something as simple as read a PDF and pick out all the names, right? Name identity recognition, right? Adding these structures on top of unstructured text is something that it turns out is really easy to fine tune, or even like in context learning large language models to do. Like they're not like super exciting, right? But like they're super useful, right? You've got this like PDF, it's like complete unstructured, and then you feed that into a large language model and say, now pick out all the proper names. Now pick out all the triplets of subject, verb, object. Those can be useful primitives that you can then use to power more. So then going back again to like the chat, for example, right? Being able to translate and recognize these like recurring patterns in a structured text, translating from unstructured to structure, I think is also a very interesting application of these models. So those are some things that I'm excited about. Another way of thinking about it is thinking about composition, right? Decomposing the overall task of querying over your knowledge base and trying to do knowledge work into structured tasks, like find me things in a database that are contradictory to the thing I'm trying to assert, and then try to stitch together these 5 things into an outline, right? Those like kind of structured things where they're very scoped, but you can easily tell if they're doing a job. I think that pattern also has promise. This is something that's done by LangChain This is done by Illicit, trying to think about these kind of decomposition approaches. I think it's promising also.
So, Joel, usually the last question we ask folks is that what's the most important thing people should know about your area that's not obvious?
Yeah, I was thinking about this. So we traced my trajectory a little bit, right, from cognitive science to human-computer interaction to now information studies. And I mentioned a little bit, CSCW. I think one of the ideas that I think is really powerful but non-obvious is how much of knowledge organization and sharing and production is a social, negotiated process, right? Like, what do we classify something as, right? Is this an A or a B? Often is not a question of correctness, but it's a question of what's useful for whom, under what circumstances. And if you lose sight of that and try to think about, let's find the best classification system, let's find the correct way to classify this in all cases, you're actually not going to produce very useful system. But instead, if you, like I said, always put the users in control to negotiate which structures do we actually care about now, even if it's not like correct or complete, but this is what's super useful for us now, right? That's the design implication of recognizing the social nature of knowledge organization. I think that's a very important idea that I think would be very useful for designers to keep in mind as they're building these systems for knowledge organization.
I feel like we can continue this conversation for another 24 hours. Unfortunately, we have to wrap it up. And I'm really hoping, Joel, that we can bring you back, in a few months to pick up this conversation again. I think there is a lot more to be seen about, large language models like GPT in the next few months, because, the excitement is going to settle down a little. Yeah. And, the real use cases and the real applications is going to, start being more visible. And I'm more interested to also see how, as you said, I completely agree that large language models are best used as essentially as NLU layers versus, any source of, factual knowledge. Yeah. So I'm also very excited to see how these models are going to interact with, structured databases that we've been using, be it tabular, be it graph database, knowledge graphs, taxonomies, etc. So excited to see there is a lot of research going on them, especially in the past 2 years. Yeah. So excited to see more applications of those. Thank you so much for joining us on this show. It was a very fun conversation. I think, based on this conversation, I'm going to have a chat with Amar to do a couple of pivots in the product design that we are doing. So I'm excited to probably show you that very soon as well, Joel.
Wonderful.
But thank you so much for spending time with us. Thank you so much, audience, for listening to us talk about all these very exciting topics, and hope to see you next week again. Thank you.